Then I'll put off the transcription. Okay. So, John, can you hear me? John? John? John, can you hear me? Yeah, so John, I would like you to unmute yourself so that. Okay, so let me get in touch with you.
This online promotion thing that they have introduced.
Hmm.
I don't think it's going to be effective.
The online can. I'm just looking to see how it will. Okay, so just so that John is listening, today we are looking at inductive reasoning, and like we said in our last class, it's in contrast to deductive reasoning, because whereas for deductive reasoning, the relationship between the premises and the conclusion is a logical one, it doesn't apply to inductive reasoning. And for deductive reasoning, what really matters is the relationship between the premises and the conclusion. But for inductive reasoning, that relationship does not matter as much as what you could interpret from the meaning of the contents, the meaning of the contents of the argument. Now, so for inductive reasoning, the relationship is not logical, and that's why it is possible to affirm all the premises and deny the conclusion without contradiction. Steve. And also, for inductive reasoning, the premises are capable of producing more than one conclusion. So when you are dealing with inductive reasoning, you need to look at the meanings of the contents of the argument, and then you also need your common sense reasoning to determine what kind of conclusions you would prefer to an inductive argument. Now, in an inductive argument, the premises provide reason for believing in the likelihood of the conclusion. But the premises don't really guarantee the conclusion. And so for that reason, we say that inductive arguments are, we call them probability arguments. And because inductive arguments do not depend on rules, they are harder to evaluate. In fact, my own definition of inductive arguments is that they are arguments saddled with more than one possible conclusion, because premises support but do not guarantee the stated conclusion. Now, to understand inductive arguments, inductive reasoning, we need to clarify between verifiable and confirmable statements. Verifiable statements are statements we can directly test or verify. They are usually factual or empirical statements. Example, Kofi lost strength with age. Now, on the other hand, confirmable statements are those statements that we cannot test or directly verify, except through verifiable statements. Example, all men lose strength with age. Now, we can combine verifiable and confirmable statements in an argument. Normally, in an inductive argument, verifiable statements are the premises, and then confirmable statements are the conclusions. Now, in this example, you have 4 verifiable statements as premises and 1 confirmable statement as conclusion. Kofi lost strength with age, Peter lost strength with age, Michael lost strength with age, James lost strength with age, therefore all men lose strength with age. Now you can see that the premises are verifiable statements leading to the conclusion, which is an unverifiable or confirmable statement. Now let's look at another example. Mary reached menopause by 40. Grace reached menopause by 35. Meredith reached menopause by 33. Rose reached menopause by 34. Edith reached menopause by 38. Sophia reached menopause by 45. Therefore, half of all women will reach menopause by 35. Now, so this is another example of an inductive argument. You can see that half of the premises are referred to women who reach menopause before or by 35 years of age, and the other half of the premises refer to women who reach menopause after 35. So the conclusion is based on the statistics presented by the premises. Now let's look at 2 ways of detecting confirmable statements. And the question really is, how do I detect confirmable statements? How do we detect confirmable statements? So there are 2 ways. First of all, confirmable statements are not directly testable or verifiable. Secondly, they can be converted into conditional statements. Example, look at the following categorical statement. No leader steps down from power unless compelled by a coup or constitution. No leader steps down from power unless compelled by a coup or constitution. Now, to translate it into a conditional, if X is a leader, then X will not step down unless compelled by a coup or constitution. Okay, so it's impossible to convert directly testable statements. Now, it's only confirmable statements that you can convert to conditional statements. You cannot convert verifiable statements into conditional statements. If you like, you can practice it and see. Now, a statement that is directly verifiable or testable cannot be converted into conditional statement or version. Kofi lost strength with age. Would you say if a man is called Kofi, then such a man lost strength with age? No. So that would mean that all men called Kofi are old, and there are no young people or children called Kofi. Neither are there any strong young people called Kofi. So verifiable statements are usually about particular people or particular things. To make them conditional statements is to somehow make them universal statements. A conditional statement usually applies to a general statement, not a particular statement. Now, let's look at another distinction between finite and infinite reference classes. Now, you remember we made this distinction in our last class. We had said that the finite reference class refers to the class of countable items. Examples, this copper, that man, some boys, that table, etc. And then the infinite reference class is a class of uncountable items. Example, all metals, all men, all voters, and so on. Now, that distinction is very important in understanding the distinction between law-like and statistical hypotheses. Now, law-like hypotheses are confirmable statements that refer to all members of a class. Confirmable statements that refer to all members of a class. That is, confirmable statements with the infinite reference class. Example, all metals expand when heated. Or if X is a metal, then X will expand when heated. Another example, all F's are G's. If each F is a G, no F's are G's, that is, all F's are not G's. So these are confirmable statements with the infinite reference class. Now, law-like statements are highly predictive. Now, G must be attributed or not attributed to every F. All men are mortal. If Peter is a man, then Peter is mortal. Anything that is immortal is very predictably mortal. So when you are talking about something that applies to all the items in a class, any item you identify as a member of that class should, or let's say must, have that property or quality. That's why we say that law-like statements are highly predictive. Then you have the statistical hypothesis. Now, the statistical hypotheses are confirmable statements referring to some percentage less than 100% and more than 0%. Example, 90% of those who ate the food fell sick. So you have statistical terms such as, some statistical terms include some, few, many, most, hardly any, typically, and so on. Now, statistical hypotheses are less predictive. Now, we had said 90% of those who ate the food fell sick. If X ate the food, X is likely to fall sick. You can't say if X ate the food, X will fall sick, because it's 90% who fell sick. You don't know if X is among the 10% who did not fall sick. So the best you can say is if X ate the food, X is likely to fall sick. Now we're using the likely because X, there are 90%. X has 90% chances of falling sick. Now, inductive arguments are aimed at confirmation. Deductive arguments are aimed at proof. Now, confirmation is not proof. So evidence confirms but does not prove the truth of a hypothesis. Now, so there is a limitation of evidence, which we are going to see very soon. But before we see that, let's look at two major ways to detect inductive arguments. Now, inductive arguments are capable of more than one conclusion. That's the first thing. The first thing about inductive arguments is that they are capable of more than one conclusion. Okay, so sorry. Now, proceeding from our assertion that inductive arguments are capable of more than one conclusion, we may look at this example. 90% of those who ate the food fell sick. Amma ate the food. So there are two possible and very legitimate conclusions. You have Amma fell sick, Amma did not fall sick. Each of these conclusions is legitimate. That's why we say that inductive arguments are capable of more than one.
Hello, sir.
Yes.
I'm sorry to interrupt. Please, we just got the link, and I'm sure some of my colleagues are yet to join. So I don't know if we can wait more.
Okay, so how many are we now? We are 7 people. And this is a 5:15. Okay, so let's wait a little longer, and I would let me see if I can pause the recording. Now the recording doesn't seem to have a pause. I wish the recording had something like a pause. It only has stop. Now if I stop it, it means and start again, it means we'll have 2 recordings. So I think that those who are not here yet would need to watch the recording. In fact, when I began with just 1 person, and I was not even aware that now we have an additional 12 people. So that's good. So what I'll do is to slow down. And fortunately, we are on a slide that shows the fastest way to identify an inductive argument. And that is that inductive arguments are capable of more than 1 conclusion. Now you can see these arguments. 90% of those who ate the food fell sick. Amma ate the food. Now, so this argument gives you the possibility of more than 1 conclusion. If you say Amma fell sick, you are right. If you say Amma did not fall sick, you are right, because Amma could be among the 90% who fell sick and could also be among the 10% who did not fall sick. That's why we say that inductive arguments are capable of producing more than 1 conclusion. So that's the number 1 way of detecting inductive arguments. Now let's move on. What's the second way of detecting inductive arguments? The second way is that inductive arguments are extrapolations. Extrapolations. An extrapolation is an activity that smuggles in information into the conclusion that is absent in any of the premises. An activity that smuggles information into the conclusion that is absent in any of the premises, or information that cannot be accounted for in the premises. All inductive conclusions contain information that are not accounted in their premises. Now, let's look at this technicality, or let's understand why it is that way. For instance, or for example, a known thing A has certain properties, such as X, Y, and Z. Another thing B also has the same properties X, Y, and Z. Now, A also has some additional property Q. Now, on the basis of the above 3 premises, the argument concludes, in reality extrapolates, that B also has the additional property Q. So the idea of induction then is that if B is like A in some respects, it may also be like A in other respects. But the problem is, how are you sure that B has Q just because B has X, Y, and Z like A? So you can see that the conclusion that B has property Q is not in any of the premises, not in the premises. The premises only tell you that A has X, Y, Z, B has X, Y, Z, and then A also has Q. That's all the premises are saying. Now, so if the conclusion says B also has Q. He didn't get that from anywhere in the premises. So that's number one. And then you see that when we were looking at deductive arguments, when you saw deductive arguments in our last class, you see that the deductive arguments, their conclusions are constructed from the premises. For deductive reasoning, the premises are used as building blocks to construct the conclusion. And in fact, you construct the premises in a mathematical way into the conclusion. You saw that very clearly in deductive reasoning. But in inductive reasoning, you will see the conclusion containing something that doesn't come from any premise. Something was smuggled in there. Something is there that is just a product of guesswork. So now we have different directions of extrapolation. That's why we say that inductive arguments are extrapolations. Now we have directions of extrapolation. First of all, now this one is not in your textbook. If you want to get some of these details, then it means you have to go for the critical thinking textbook in the bookshop, the one that is colored red. So first of all, you have part-whole extrapolations, attributing something to a whole that constitutes a part or parts. Now you have two types of part-whole extrapolations. You have generalizations and you have statistical syllogisms. Now a generalization is something like Peter is strong, James is strong, therefore all men are strong. That's a generalization. And then the other type of part-whole syllogism, this one constructs a conclusion from the general to a particular. Most Canadian university students drink alcohol. Caroline is a Canadian university student, therefore Caroline drinks alcohol. So this is a statistical syllogism. Now you can see that the conclusion contains something that is absent in any of the premises. In fact, from the last example we saw, from the example of generalization, you see that the conclusion contains something that's absent in the premises. Peter is strong, James is strong, all men are strong. What is in the conclusion that is not accounted for in the premises? It is all men. When you tell me that Peter is strong, James is strong, Peter and James cannot be all men. So if the conclusion is all men are strong, then the all men was imported into the conclusion without even minding the premises. So the conclusion contains a borrowed information. Information somehow is borrowed. So that's why we call it an extrapolation. And then you check the other one, you also see an extrapolation. Most Canadian university students drink alcohol. Caroline is a Canadian university student, therefore Caroline drinks alcohol. Now we are told that most, but not all, drink alcohol. And then you say Caroline is a student. And on the basis of that, you say she drinks alcohol. Yeah, but it could also be that she doesn't drink because it's not all that drinks. So the information that she actually drinks, doesn't come from the premises. There's no premise that tells you that she drinks alcohol. No premise gives you the reason to believe she drinks alcohol, but it has been reached as a conclusion that she drinks alcohol. So the information that she actually drinks alcohol, is borrowed without minding the premises. It comes from elsewhere. So it's an extrapolation. Then you have analogies. This is another direction of extrapolation. Arguing that something possesses the same thing as another because they both possess some other properties. I think we saw that technicality earlier on. A has X, Y, B, Z. B has X, Y, Z. A also has Q. Therefore, you conclude that B will also have Q. because they have some other things in common. So that's an analogy, arguing that something possesses the same thing as another because they both possess some other properties. So example, the structural adjustment program was good for Cameroon, which is a third world country. The structural adjustment program was good for Uganda, which is a third world country. The structural adjustment program was good for Senegal, which is a third world country. The structural adjustment program was good for Nigeria, which is a third world country. Therefore, the structural adjustment program must be good for Togo, which is a third world country. Now, this argument is basically saying that because these are all third world countries, whatever worked in some of them will automatically work in another. That's what the argument is saying. But there's no guarantee that something that worked in one third world country could work in another. In spite of the fact that they are all third world countries, their leaderships might have different levels of responsibility or responsible governance. And so a third world country could be progressing, another third world country might not be progressing because their governments have, are different in terms of good governance. The government of one could be good, the government of the other one could be bad. So just because they are third world countries doesn't mean that something that is introduced in one and worked very well would also work very well in the other. So that's why we say it's an inductive argument. It's not, there isn't enough information in the premises to reach this conclusion. So the conclusion that this program must be good for Togo, it's not a conclusion, it's not an information that you get from the premises. There's no premise that tells you it will be good for Togo. All they tell you is that it's good for another country. So the information that it is good for Togo was imported without the premises, without even minding the premises. So that makes it an extrapolation. And that also tells you that an analogy is also another form of extrapolation. Then you have the predictions, attributing a quality to a future event because of the level of frequency of past occurrences of the same quality in similar events. Attributing a quality to a future event because of the level of frequency of past occurrences of the same quality in similar events. So, for example, Tyson has won his last 30 boxing fights. Therefore, Tyson will win his next boxing fight. Now, the conclusion contains something that is not in the premise. That Tyson would win his next boxing fight, you can't get that from the premise. The premise only says he won his last 30 boxing fights. So the conclusion is just projecting something that doesn't really depend on the premise. Now, Tyson could lose his next boxing fight, and that will show you that the conclusion was not really based on the premise. Now, so those are the different directions of extrapolation, and you saw that in each type, the conclusion contains something that cannot be accounted for in the premises. Now, we have two kinds of enumerative inductive arguments based on strength. Now, basically, two kinds of inductive arguments based on strength. An enumerative argument is an argument with many premises, enumerating the premises like a list. So that's why we call it an enumerative argument. And we'll see such an argument in the next slide. So the first kind of inductive argument is the arguments with the law-like hypothesis as conclusion. Those with the law-like hypothesis as conclusion. Example, you have 10 premises here, 10 premises explaining that 10 different metals expanded when they were heated. Premise 1, gold expanded when heated, silver expanded when heated, bronze expanded, copper expanded, and so on. Now the summary premise says that all the metals tested so far expanded when heated. And then the conclusion says all metals expand when heated. Now you notice that premises 1 to 10 are particular and verifiable statements. Even the summary premise is a particular statement and also verifiable. It refers to all the metals tested. And by all the metals tested, it means 10 metals, not all metals. But the conclusion refers to all metals. So that's a different ballgame because all metals include all the metals that we have not even discovered in the ground. All the metals till eternity. So there's a basic difference between the premises and the conclusion. The premises are all particular statements. The conclusion is a general statement. And then the question is, how do you conclude? How do you make a general conclusion from particular statements? How logical is the jump from the particular statements to the general statement? And so we can call it an illogical jump, a jump that is not logical from particular statements, general statements. Now, it means that the general statement, the general nature of the statement, the general nature of the conclusion is not accounted for in the premises. So the general nature of the conclusion is something that was imported without even minding the premises. So look at the technicality. Premises 1 to 10 are verifiable or particular statements. Summary premise is a summation of all the verifiable premises. Then the conclusion is a confirmable or general statement. So the argument is strictly invalid because it involves jumping from verifiable to confirmable statements. And that's the reason why confirmation is not proof and inductive arguments are not valid. Now, in fact, or as a matter of fact, that particular conclusion is false because some metals, in fact, do not expand when heated. They are called superconductors. They do not absorb heat and therefore they do not expand. So the conclusion is false and all the premises are true. And that's why it is possible to deny conclusion with all true premises or affirm the premises and deny the conclusion. So in an inductive argument, you can affirm all the premises and deny the conclusion without contradiction. Now that's applicable to all the types of extrapolation, the part whole, analogies, and the predictions. Now, having seen the technicality of of conclusions and inductive arguments, and before we look at the other type of inductive argument, let's look at a little comparison between inductive and deductive, or between deductive and inductive. Now, one of the major differences between deductive and inductive arguments is the issue of accuracy versus providing information. Accuracy versus providing information. Now, deductive arguments are accurate at the expense of their inability to provide information. Now, let's look at the following examples of deductive statements. Now, either it is raining or it is not raining. That's a disjunctive syllogism. Either it is raining or it is not raining. Now, it is 100% accurate. Now, either it is raining or it is not raining, it's always accurate, whether it is raining or not. If it is raining, the statement is accurate. If it is not raining, it is accurate. So in all situations, the statement is accurate. Or let's say it is accurate at all times. What does it tell us whether it is raining? It doesn't. It doesn't give us an idea of whether it is actually raining. So you can say that this statement is accurate at the expense of its inability to provide information. Now, the second example, if it is raining, then someone will get wet. If it's raining, then someone will get wet. Now, that's a conditional statement. It tells you what will happen if it is raining. Now, that statement is accurate because if it rains, not all of us can avoid rain totally. It must touch on someone. And so, when you say if it is raining, someone will get wet, the statement is completely accurate. The statement is completely accurate, 100% accurate. If it is not raining, the statement is accurate. If it is raining, it is accurate. The statement is accurate at all times. But does it tell us whether it is raining? It doesn't. So you can say it is another example of a statement that is accurate at the expense of providing information. So I'm just using these sentences to teach you the difference between being accurate and providing information. Now, on the other hand, inductive arguments provide information at the expense of accuracy. Now, that's because providing information is to be falsifiable. When you provide information, the information you provide is falsifiable, especially empirical or factual information. Any empirical or factual information is falsifiable. For example, it is raining right now. It is raining right now. Now, it is raining right now is falsifiable. It gives you, does it tell you whether it is raining or not? Yes, it tells you that it is raining. It tells you it is raining right now. Is it falsifiable? Yes, it's falsifiable. If it is not raining right now in my office, then this statement, it is raining right now, is false to me. So it is falsifiable. Now, falsifiability and science. Any valuable empirical information must be falsifiable. Any statement that is not falsifiable cannot be a verifiable or confirmable statement. Any statement that is absolutely true has no empirical content. So if there's any empirical content, that content must be falsifiable. Now, the more valuable the empirical information, the more falsifiable. Now, there are two statements. Look at the two empirical statements. It rained just now, and it rains every third Friday of the month. The empirical statement, it rains every fourth Friday of the month, is more valuable information than it rained just now. If you are told that it rains every third Friday of the month, then you will make arrangements. You probably decide not to go out on Fridays, or you probably decide to embark on a sporting activity that depends on rain. Whatever it is, you make arrangements that is valuable every third Friday of the month. So that information is more valuable because it helps you to achieve more compared to the statement it rained just now. Now, the more valuable the empirical information, the more falsifiable. So it takes only one third Friday of not raining to falsify the first statement. Now let's look at the second type of inductive argument. Arguments with statistical hypotheses as conclusion. Now this is an example. Premise 1, Michael was vaccinated for polio and never suffered polio. Gilbert was vaccinated for polio and suffered polio. Mary was vaccinated and never suffered. Stanley was vaccinated and never suffered. James never suffered. Bob was vaccinated and suffered. Jill never suffered. Samuel never suffered. John never suffered, and Carol never suffered. So the summary premise says 8 out of 10 people who were vaccinated for polio did not suffer polio. And then the conclusion is what? That polio vaccination has 80% potential of preventing polio because 8 out of 10 stopped suffering polio. And so this conclusion is what we call a statistical hypothesis. Now, so there are 2 types of inductive arguments. The ones ending with law-like hypotheses as conclusions and the ones ending with statistical hypotheses as conclusions. Now you can see that it is actually more prudent to make statements that have to make statistical than law-like hypotheses. Law-like hypotheses are much more difficult to support or to confirm, but the statistical ones are easier to confirm. Now, hypotheses are technically regarded as conclusions of inductive arguments because they are confirmable statements to be supported, confirmed, or denied by verifiable statements. So that's the end of the class, and you can see that all these are ways of identifying inductive arguments. You have arguments with statistical hypotheses as conclusions, and arguments with law-like hypotheses as conclusions. And you can see that in all of those arguments, the premises give you the possibility of more than one conclusion. And also, you can see that in all of those arguments, there is information in the conclusion that is not accounted for in the premises, in any of the premises, or even in all of the premises put together. So at this point, I'm going to pause so that we take questions. And before I start uploading the recording, I would want to attend to any questions that anyone might have so that those who could not make it to the meeting would have the opportunity of watching and listening to the recording. So any questions so that we can attend to your questions before we begin to upload the recording of your class. Okay, so if there are no questions, I'm going to proceed to stop the recording.